Okay, grade eights, here we go. Just a couple of things before I start with our next topic. You're welcome to do this a couple of ways. If you have access to a printer, you can print out the notes. I've attached a copy and you can fill them in as I'm filling them in, just as we would do in class. If not, you're welcome to listen along and just make notes on a loose leaf piece of paper. One of the nice things about having a video recording of the lesson is you can go at your own pace. So if I'm going too fast for you, well, then you can press pause, take some time to go over the example before you move on. If I'm going too slow for you, you're welcome to fast forward the lesson. So before spring break, you had finished up your unit test on fractions, and we had moved into chapter 7, which deals with ratios and rates. Ratios, if you'll remember, was comparing two quantities, which was a two-term ratio, or three quantities, which was a three-term ratio. Now, our topic today is rates. Rates are very similar to ratios in that they are a comparison. The one key difference is when we're dealing with rates, we're measuring two quantities that are measured in different units. Okay, so I'll go through some examples of rates. For example, your heart rate, you can measure your heart rate as a number of beats per minute. If you're driving, for example, in a school zone, cars have a speed limit of 30 kilometers per hour. So there's another example of a rate. So beats per minute, kilometers per hour. If you're going to the grocery store, they're going to charge you a certain amount of money per pound or kilogram of fruit. So you would have 99 cents a pound, for example. If you've done Science 8 already, density is another example of rate where we use grams per milliliter. So basically, all the examples above are comparing two different units to each other. Okay, so what I'm going to do is I'm going to focus in on the unit rate first. So I'm going to use the example of heartbeats per minute. When we say that your heart beats 70 beats per minute, another way to rewrite that is like this here, beats/minute, and that means beats per minute. The beats per minute is called the unit rate. Notice that with a unit rate, the bottom number is 1. So we have 70 beats per 1 minute. Okay, so once again, really important with unit rates, the bottom number always has a value of 1. And this is a very simple way to write it out. A more efficient way to write it out would be the way I've listed it in the notes, 70 beats per minute. So 70 beats per 1 minute. Okay, so let's look at the next example of calculating unit rates. Robert and Evan decided to go on a 10-kilometer race. Robert, who looks like he's going to be a superstar runner, took 20 minutes to run this distance. Wow, good for you, Robert. And Evan took 45 minutes to run 10 kilometers. So what are the speeds of both Robert and Evan, and who has the greater speed? Okay, so let's start with Robert first. Okay, and typically when we're dealing with rates, time will always go on the bottom. You'll get used to this as we go through the examples. So Robert ran 10 kilometers in 20 minutes. Now we want to know his speed or his kilometers per 1 minute. So that's the key here, 1 minute. And I divide by 20. Whatever I do to the bottom, I do to the top. So I divide this by 20. So 10 divided by 20 is 0.5 kilometers. So Robert's speed then is 0.5 kilometers per minute. So 0.5 kilometers per minute. And let's look at Evan. So Evan also ran 10 kilometers. He took a little bit longer. He took 45 minutes. And we want to know we want to know his speed. How much did he run in 1 minute? So we divide the bottom by 45 and we do the same thing to the top. We divide it by 45. You could also use cross multiplication here, and using our calculators we get 0.22 kilometers per 1 minute. So Evan's speed then is 0.22 kilometers per minute. So who ran faster? So per minute, Robert ran much faster. So we'll just put a check mark there. So underneath here are some examples for you to try. We want to calculate the unit rate for each of these. So what I'd like you to do is just pause the video, try the examples, and then double check your answers. Okay, so the first example, Brandon runs 150 meters in 25 seconds. So how much does he run in 1 second? I had to divide that by 25, so I do the same thing to the top. I divide it by 25, and there is his unit rate. He runs 6 meters in 1 second. So that's our unit rate, meaning the bottom number is 1. And a fancier way to write that out is 6 meters per second. I prefer this method here, 6 meters per second. Example 2, Kira earns $88 for working 8 hours. This is another example of where you'll learn these patterns. Money always goes on top, and then time, I've mentioned it before, always goes on the bottom. So she earns $88 in 8 hours. How much does she earn in 1 hour? So I divide the bottom by 8, divide the top by 8, and I end up with $11 per 1 hour. So this here is my unit rate. And a more efficient way of writing that out is $11 per hour. And example 3, cat food costs $9 for 5 cans. So money always goes on top. So we know that we have $9 for 5 cans. What is the price per 1 can? So notice with the unit rates, the bottom number is always supposed to be 1. So we divide it by 5, and we divide the top by 5 as well. And we end up with $1.80. So here's my unit rate. And a fancier way to write that out is $1.80 per can. Okay, so on the back side now, we're going to use we're going to compare prices using unit rates, right? So a lot of times we go into the grocery store and there are different sizes, for example, different sizes of soup cans, different sizes of laundry detergent, and they each cost a different amount. And we want to know, where are we getting the best deal, right? We want to make budget conscious choices. So what we're going to do is we're going to do a couple of examples here where we compare different sizes. So in the first example, Edison went to his local grocery store to buy some apple juice. He found 3 sizes and the prices are listed below. So typically we think we're getting the most bang for our buck when we buy the largest size, right? The more you buy, the cheaper it is typically, but sometimes items can be on sale, and sometimes a store might not have it set up that way. So which apple juice container is the best buy? So one of the things we need to do is make sure that we have the units need to be similar. So we have here 350 mils, we have 960 mils. We need to change the 2 liters into milliliters as well. And if you'll remember, 1 liter has 1,000 milliliters. So before I start, I'll just cross that out and write down 2,000 milliliters. Okay, which apple juice container is the best buy? So let's start with container number 1. And I've taught you that money always goes on top. So $1.50 for 350 milliliters. We're calculating the unit rate here, which is known as the unit price in this case. Typically, I would have said, okay, put 1 milliliter and find the price per 1 milliliter. One of the problems that would arise is we would have our cents be in the decimals, might be 0.0003 or something like that. And that's not how we normally speak, and that's hard to understand. So when we are doing unit prices, we always use the bottom number. We don't do 1 milliliters. We always use a standard of 100 milliliters, okay? That way we can make sense of the money. So in this case here, I would probably use cross multiplication. I would say, okay, $1.50 times, so 1.5 times 100, press the equal sign, divide it by 350, and you would get 43 cents. So be careful to round up or not round because we're dealing with money and the numbers will be quite close together. So the first apple juice container is 43 cents per 100 milliliters. So you can imagine what would have happened if I had wanted the price per 1 milliliter. It would have been a very, very small number. So now let's do the same thing for the second container. The second container costs $3.99 for 960 milliliters. We want to know the price for 100 milliliters, and we're going to use cross multiplying. 100 times 3.99 divided by 960 gives us 42 cents. So you can see they're quite similar. So very important that you're rounding up your decimals or leaving them as is when you need to. Okay, so the third example, we have $5.99 for 2,000 milliliters. We want to know the price for 100 milliliters. We use cross multiplying once again. 5.99 times 100 divided by 2,000, and we get 30 cents. Okay, so if we compare the three, this one ends up being the best buy. You only pay 30 cents for 100 milliliters. Okay, I would like you guys to try the next example. So same thing, you can pause the video here, try it, and then check over your answer. Okay, so I hope you tried that example, and I have written out my work here as well. So the first container of salsa, remember we're finding the price per 100 mils, and remember best to just use cross multiplying, and I got an answer of 81 cents. Okay, the second container, $6.29 for 642 milliliters. Remember, money's always on top. We want to find the price per 100 milliliters, so we use cross multiplying again, and I ended up with a price of 98 cents per 100 milliliters. And then the third container, the original the original volume was 1.7 liters, so I changed it to milliliters, and I used cross multiplying or dividing both of them by 17, so 100 times 15.49 divided by 1700, and I ended up with 91 cents. So the cheapest brand, or the best buy, is the smallest container in this case. Maybe it's on sale. So this one here is the best buy. And now you can try, we can do this together. We're almost done. 2 brands of canned dog food are on sale. Assume the cans are the same size. Brand A costs $13.60 for 8 cans, and brand B costs $8.75 for 5 cans. Which brand provides the best value per can? Show your work. So brand A is $13.60. Remember, money's always on top with unit prices for 8 cans. What is the price per 1 can? So we divide both of them by 8 or use cross multiplying, and we end up with $1.70 per can. And brand B is $8.75 for 5 cans. And what is the price per 1 can? We end up with $1.75. So this one here is the best buy. It's cheaper.